hello everyone, I am Vipin Kumar Maurya and today I will demonstrate Juno 3B handheld GPS receiver. So let's start. So this is the Juno box. You can see here this is the quick start guide, the informations, and this is the Juno 3B. You can see here it's a Juno 3B. This is the battery. It can give backup around 10 to 14 hours for this device, and this is the charger. So first we will have to fix the battery. So you have to open this, and as per the socket we will set here. Now it's okay. So this is how we have to hold this. Take this in your hand and we can hold this. So to start it, just click this power button once and it will start. It's starting. In the meantime, we can see this is the earpiece. This is the point for the external antenna. This is your camera button. This is your other buttons. This is the start button, and here we can see the micro USB port, and this is for charging. And to control all the functions we have stylus also. So now you can see this is the home screen. In this window we can open this, and as we will be using this software, this is TerraSync. So you have to just click one time and it will start. So we can take any edition for the demo purpose. So this is the start button. You have to click here, and this device uses the TerraSync software. So click once here and starting. For demo purpose, start with the standard edition. Here we can see now it is connecting, and it will search for the satellites. So here we can see the number of satellites. This plot is called sky plot, and this is showing for the corrections. So once the satellites are logged, we can see here the number of satellites. So till it is searching for satellites, so first we have to make a project. So first go to setup. First we have to complete the settings. So first one is the logging setting, means in what manner we want to take the data. So first one is the accuracy setting. Here we can see whatever we want to see on the screen in the field. This is it is asking for the time of the device. So first we have to reset that one. So first we have to click on start, and this device is a TerraSync software from Trimble. So click once here. For demo I am taking the standard edition. So this window is showing the sky plot. Here we can see the number of satellites. So first what we have to do, first we have to go to the setup. First we have to complete the primary settings. The first one is the logging setting. So here we can set the accuracy setting, like we want to see in horizontal or vertical. So you can change here horizontal or vertical in the field, or after the processing we want to see that. So, and this option is use accuracy based logging, means if we want to take the observations according to accuracy. If accuracy is high, to take you have to select to take the data, and if it is not, so no data will be taken. So this is done. And what are the other options, like what is the antenna height? 1.4 meter. And do you want to be updated after taking the position? So this is the allow position update. So yes. Confirm end feature. Yes, it will confirm that the end feature has been taken. You can see any file name prefix, waypoint file name prefix. So these are the settings. And there is an option for style and interval. I will explain it later. So done. We can go for the Genesis settings, like at which port you want. So Genesis receiver port COM4, and these are the default values for dilution of precision. So which DOP type? It is PDOP, precision. And then the information of maximum SDOP, minimum SNR, minimum elevation. And what about the output? So this is also okay. If you want real-time corrections, you can choose here. So if I select integrated S bus, so our accuracy will increase, and if I select use uncorrected Genesis, then accuracy will decrease. So we'll see what are the effect of selecting S bus or the uncorrected Genesis. So the next one is the coordinate system. Here you have to select about the system, the datum, whatever altitude you want, and what are the units. So let it be as it is. And about the units, about the distance, area, angle, latitude, longitude, degree, minute, second, or degree. So these are the other settings. So now setting is complete. We can go for to create our project. Here at the top we can see now there are 6 satellites, and if we see the sky plot, this is the, here you can see Genesis calculating positions 6 GPS satellites. So we'll see the sky plot also. So first of all we have to create a project. So this is the new one. So from here we can also see like existing file, or we can go to file manager to select other, means previous jobs. So for this job I have selected this as a rover. Location is default, and the file name, so I am writing it as demo. Okay, and this is the very important option, dictionary name. So if I am taking it as a generic, so only point, line, and polygon will be taken. And if I want to add other attributes of the line, point, or any polygon feature, so I can create the dictionary. I will show it later. So now the job is created. So what is the height? 1.4 meter, and the antenna type Juno internal. Now we can take the points, but we have to wait for more number of satellites. Because satellite is less, so we can see here the horizontal accuracy is around 19 meter. So we will wait few times and let the satellite number of satellites increase. We can soon see now this is 6 number of satellites now, and the accuracy has been increased. Now it is 8.3 meter in horizontal. So we can see about the satellites also. So if I click on the status, we can see here the number of satellites being trained. So this is the north, and these are the satellites, and this is the PR number 21, 07, 17, 19. Now these are the satellites being tracked. So now we can see there are 7 satellites here, and the accuracy is fluctuating. It is 11 meter. So if you can remind, let's go to the settings again. And here we can see the real-time settings. So let's select integrated bus for real-time corrections. So now we can see from 11 meter, now it has come to 8 meter. And let's wait for some time, so the accuracy may increase. So now we have got something positive. There are 10 number of satellites and the accuracy is around 4 meter. As in the standard it is also given like the accuracy will be in 3 to 5 meters. So I think now we can start our work, our survey. So as a point, what are the features that we can take? We can take the location of pole or any tree or any other things. In the line we can cover the roads or any line feature. In the polygon we can cover any park, playground or anything. So let's start the survey. So just click on the point generic and we can see here now it is taking the observations 1, 2, 3, 6, 7, 8 and we can give the detail of this tree also. So generally we take 20-30 observations, so we'll wait. And once it is done, we'll click done. Now it will ask for the confirmation and set OK. And now the point has been stored. We can see on the map also. So this is the location of the point. So now let's take the options of the any line feature or the area feature. So now if you want to cover the road, so what we have to do is click on the line generic. It will start taking the data. Here we can see a pen showing the drawing the line. We can give the detail of the road and once it is done we can click on the done. So what you have to do, you have to walk. And now we can see in the map so this is the line, the black dots, and this is the tree, the black point. In the same way, if you want to cover any polygon like park or anything, so we can click on the area and in the same way we can collect the data. Now to take an area feature, click on the area and it will start taking observations and give the details of that area. So I'm starting that. once it is done, just click on done. It will ask for confirmation, click on OK, and now we can see the map. So this is the polygon we have drawn. So in this way we can collect the data here. If we talk about the settings, one thing which I have not discussed, it was the logging setting. So at the downside we can see here, once we are taking the data, any line feature or any polygon feature, so we can select it, like we want observations, one observation per every second. If I am selecting the time, if I am selecting the distance, so like in every 1 meter or in every 5 meter I want to take the observations. So here we can set it 1. So in this way we can complete our logging settings and we can collect the data. So why it is necessary, and I have told that. And one more thing, like if I am taking a line feature and in between that I got any point like a tree that I have forgot to take the observation. So what we have to do, in the way like I am taking this observation as a line, and now we can see the observation has been taken. So it is continuously taking. So suppose what I can do in the case I found any point in between that track or the line feature that I have to take the observation. So click here, click on the nest, and we can select on the point generic. So in this way we can go anywhere, we can take the point, and once point is collected, click on the done, and again you will get the option of line generic. Means on the way while taking the any line feature, you will go to the any point feature, you will collect that, and you will return again, and you will again continue the line feature. So this is one means good option in the data collection. So once you click on the done, the data will be collected. One more thing, you can see in the starting, while creating the new job, what we had done, there was an option of library, and we had selected the generic library. So we can see here the point generic, line generic, and area generic. So let's see what happens if we select any other library, what a library can do for us. So in the data option, now what we will do, we will create a new job and select any library. So go to the data first. Here we can see the name of the file, let it be here, and in the library I am selecting the GEOMATICS library. This is a library present here, and create. So we can see in this library there are many features have to be collected, and in that way the library has been created. Like if you want to take the road, click on the road. You want to take any signpost, you can take it. You want to take any light pole. Suppose I want to collect this light pole. So I will stand here and I will click on the light pole, and we can see here like what is the pole entry, first, second, third, pole type, and what is the condition. Is it okay? Yes, it is okay. So we can give the options. There are option of the photo also. So what you have to do is just select the photo option, and your camera will start. This is a 5 MP camera in this device, and you have to just click, and it will take the photo also. So the photo of the JPG photo is here. You can see downside here also. So this is the beauty of the data dictionary, what we call. So this data dictionary help us to collect the other information, the attributes of the features. So like for this pole, we can take the condition of the pole, the photo, and if any note we want to add with this. So this could be done with the data dictionary. So once you click done, it will be collected. You can see on the map also. So this was a new file, or you can see here the symbol of the pole is also shown. So in this way, if you create your data dictionary, you can collect the data in very unique way. So these are the options: map to see what are the data you have collected, data to collect the data and to create the job, navigation if you want to navigate to any point, status to show the satellites, and setup are the whole setting. So once your data collection is completed, you can click exit, and it will be